This is my submissions for Physics Lab 4. And to get into it, our introduction. The purpose of Lab 4 is to examine the motion of a spring mass system while it is swinging an arc and oscillating on a spring. Our system for this experiment is going to be the spring mass object. Our surroundings, there is none because it is isolated. And of course, we use tracker to observe the position of the object over time. And we use GlowScript to create a computational model of the object using the template given to us in Canvas. And our goal, we want to determine if the spring mass system follows the energy principle. And to spoil a little bit, the result, the spring mass system follows the energy principle because the system's total energy stays at a constant 0. And to go over some physics concepts, the net force of a system with respect to its change in momentum over time is Newton's second law. And we always include Newton's second law in our experiment because it's very important. And so from Newton's second law, from Newton's second law formula, we can derive the position update formula and velocity update formula, which is useful in many conditions. And of course, we need to use our energy principle in this lab, which is the change in energy is the sum of energy exchanged with the system and work done by surroundings. And as you can see down here, the energies added up for our experiment is going to equal 0, which is the same as from our result. And from our tracker here, I took a screenshot of the graphs I was given. And here you can see that I was tracking its center of mass at each position with the video given to us in Canvas. And from that, I can calculate the oscillation period, which is given with the formula up here. And for me, I got T is equal to 1.5186. And from that, we can calculate the spring stiffness, which we can calculate inputting data into this formula. And for me, I got 6.87 N over M. And our relaxed length, or L naught, is equal to the magnitude of L minus mg over k, which for me, I got 0.127 meters. And to go over some of our initial conditions for our coding, we were given the mass of the ball, or mass of the system, which is 0.402. We inputted our data from tracker for our initial conditions in this position. And of course, this gravitational constant on Earth is 9.8. I inputted the spring constant calculated from the previous slide and the relaxed length from the previous slide. And from another big chunk of coding, as you can see up here, I input the formulas for L hat, and S. Down here, I inputted the formulas for kinetic energy, gravitational potential energy, spring potential energy, and total energy. And below that, which is another big chunk of coding, I have to calculate the force of gravity, which only affects the Y position, spring force, net force, which is spring force plus gravity, the ball's velocity, ball's position, and again, to give our loop, we have L hat, and S, and etc. Down here, we have calculated the energy changes, and all the way below here, we can see that the total energy should be equal to 0. And so from our code, we have two graphs on X and Y, and as you can see from the red and blue lines, there are some discrepancies between our tracker data and our computational model. And to get into the reasons for why, it might be because I got lazy and didn't accurately track the center of mass at each time, causing issues in the position. And the system isn't actually isolated in the experiment video, so there are forces acting upon the system in the real world. And to continue on to our questions, did the experiment satisfy the energy principle? Yes. And the reason why can be seen on the orange line. Considering our system is isolated, the orange line is flat, and therefore shows that the total energy change is 0 throughout the entire experiment. And finally, to find oscillation at X and Y, I first calculated in the X direction, which is obviously different from my Y direction. And in conclusion, oscillation at X and Y will produce different spring stiffness or spring constant. And so ultimately it just shows how finding oscillation periods at X and Y will be different because the data is different.